Okay, so good morning. I am Stephanie Laving and I'm the team specialist. I am a second-year PhD student in music, health sciences, and neuroscience. I'm also an accredited neurologic music therapist. Chadwick Chuxi and Matan Winstock are the team programmers, and they are both master's students in computer engineering. So together, we've developed the app iPhasia. So the goal of our app, iPhasia, is to help people living with Broca's aphasia recover functional speech. And by functional speech, we refer to communicating basic wants and needs. Aphasia is an acquired language impairment. It's highly prevalent, and Broca's aphasia is only one subtype. So these individuals understand language, they know what they want to say, but they cannot say it, although it was observed that they could still sing. So a speech technique called melodic intonation therapy, or MIT, was developed to carry these individuals from singing to speaking functional sentences. So the mechanisms behind MIT are twofold. So first, rhythmic entrainment, which consists in finger tapping to a steady metronome beat, helps coordinate the muscles required for speech production. Second, singing is observed by a different neural network than the one involved in speaking, which is likely to be intact. So to sum up, our app iPhasia is a neuro rehab platform that provides the 6 steps of the MIT protocol. So now we're going to demonstrate our app. I am a neurologic music therapist, and I'm working with a client who acquired Broca's aphasia following a stroke about a year ago. My client has been very frustrated about his inability to communicate with his wife and 2 children. So between each of our meetings, my client goes home and practices his sentences using this app, which Matan will demonstrate.
This is the main screen where you can start training, use the metronome feature and track progress. The key to the process is repetition, and throughout, you'll see a back and forth where the app asks you to listen and then repeat. So we'll select I love you. And at first, it'll ask you to just listen to the beat. And next, it'll ask you to tap along with the beat. Once you meet a minimum threshold of accurate taps, it lets you proceed. Okay, so it reminds you to keep tapping while you listen, and it'll start by playing a humming version of the melody. So for now, the user just listens. Next, it'll play a singing version of the sentence.
I love you.
Again, the user just listens for now.
I love
Next, the app will ask the user to repeat along with the app.
I love you. I love you. I love you.
We slowly start fading out what percentage of the clip is played to make sure the user is remembering what they're learning. So we'll go from 100% all the way down to 25%. And we've shortened the number of repetitions for this presentation. Next, we'll play the sentence. We'll ask the user to repeat it on their own.
I love you.
I love you.
I love you.
I love you. Some positive reinforcement. So now we want to test the user by giving them a real-life scenario in which they use the sentence. So here they just spent an afternoon with their loved ones, and it's time to say goodbye. An audio file will play, and then the user has to respond with the sentence they just learned. Once the user stops speaking for 5 seconds, the recording stops, and we generate a score based on how accurate the sentence was.
Bye. See you soon. I love you.
I love you. Okay, so they did well. So now we can go into progress and see that they did well with I love you, but there's some other sentences they need more work with. So now Stephanie will demo the therapist flow.
Okay, so my client has made great progress and is now ready to learn new sentences. So I'm going to demonstrate how a therapist would use this app. So as a therapist, I'm going to hop on my client's phone and I'm going to go in their personal account and I will hit add a new phrase. So I'm going to type in the new sentence, I am thirsty. And in the box under, I would type in the scenario that will be provided to the user in the last step of the training platform. So I'm going to hit continue. Next, I'm provided with the metronome feature, which I can decide the tempo. And this allows me to practice the sentence in order to record at the appropriate slow tempo. So I'm going to hit next. So on this screen, I can record the audio files that are required for the training platform. So I can always go back to the metronome feature by pressing play metronome. So now I'm ready to record the humming version. So I'm going to hit record hum. Next, I can press on the speaker icon to listen to this recording, assess whether I'm happy or whether I want to re-record it. So I'm going to move on and record the singing version. So I'm going to hit record sing. I am thirsty. And last, I'm going to record the sentence that will be the last prompt for the user to test and use his sentence. So I'm going to hit record test. Dad, do you need anything? Okay, so now I'm set. I have my 3 audio files, so I'm going to hit save. So now I'm brought back to the main menu, and when I go to training, I can see that my sentence was added, and I can go in the progress board and see it was added too. So now I'm going to head it over to Chadavi, who's going to explain the back-end structure of our app.
So we saw in the demo that one of our main features is metronome, and we also have a training feature, which includes metronome, stimuli, and the final test. Then we have a progress screen, which shows the user's progress, and a way for the therapist to add a new phrase. All of this data is stored in an internal module called user config, and we use the phone's local storage for storing the actual data files. We also have an authentication module so that the user can log in and access their data on different devices. So these modules for the mobile app map to Firebase Auth, and also the Firestore and cloud storage is used for storing our data. This data store is read by the training module so that it can know the metronome's beats per second to be used, the phrase that the user is learning, and to write the user's progress. This is then read by the progress screen, and we write to the data store when we add a new phrase. So in the future, we would like to allow the therapist to add a new phrase without having to use their client's phone. We want to include a melody generator so that therapists that aren't musically trained can also find melodies that fit the sentences that they want to teach their clients. And we want to include some visual cues for the user so that they can learn through imitation and watching lip movements. So some challenges we faced were translating real-life multisensory modalities that a patient would experience in a session with their therapist, human to human, and translating this into the human to mobile app interaction. This includes visual, auditory, tactile, and proprioception stimuli. And if we were to go back and start over, we would focus more on how the therapist fits into our entire application. So that was our presentation, and we will take any questions now. Thank you.